All right, welcome to the deep dive. Today we're going way back to 1908, June 30th, 1908 to be exact.
Yeah, a day that, well, shook the world, I guess you could say. Quite literally.
Definitely shook something. I mean, we're talking about the Tunguska event.
The Tunguska event.
You guys send in so many questions about Tunguska, and honestly, I get it. It's one of those events that just grabs your attention and won't let go.
Right. I mean, think about it. A massive explosion.
Huge.
Somewhere between, like, 10 and 40 megatons, and it happens over Siberia.
Siberia.
Yeah, pretty remote even today.
I mean, to give you a sense of scale, that's like, what, some of the biggest nuclear weapons ever tested.
It is, and the effects were just, well, staggering. About 80 million trees just wiped out, flattened over an area of, get this, 2,150 square kilometers.
It's crazy to try to even picture that. I mean, that's a landscape completely reshaped.
Oh, absolutely. And here's the thing. It's the biggest impact event on Earth in recorded history.
That's what blows my mind. So in this deep dive, we're going to do our best to figure out what exactly happened that morning. We'll see what scientists think caused it and why, over 100 years later, people are still so fascinated by it.
Yeah.
Now, you guys sent in some incredible stuff. Scientific papers, old eyewitness accounts, even some newspaper clippings from back then. It's really gold.
Amazing.
So our mission is pretty clear, right? We're going to look at the main scientific explanation, and yeah, we'll definitely touch on some of the, shall we say, alternative theories out there.
Good.
So first things first, when and where did this all go down?
Right. So June 30th, 1908, morning. But there's a little wrinkle. Russia was still using the Julian calendar back then, the old style calendar.
Oh, okay.
So if you see June 17th in some older documents, it's the same event, just a different calendar.
Makes sense.
But yeah, June 30th by our calendar.
Gotcha. And where in Siberia are we talking?
It happened near the Podkamennaya Tunguska River.
Try saying that 3 times fast.
Not going to happen. Back then it was in Yeniseisk Governorate. Today it's Krasnoyarsk Krai. Super remote, even now.
Okay, so super remote Siberia, June 30th, 1908. What were the very first signs that something unusual was happening?
Well, according to eyewitnesses, people saw this bluish light, almost as bright as the sun, moving super fast across the sky.
Ooh.
Yeah, leaving a trail behind it. Then, as it got lower, there was this huge flash.
I bet.
And then this massive cloud appeared, billowing up. And this pillar of fire, some people said it was red and that it actually split in two.
Whoa.
Before fading and turning black. Can you imagine seeing that?
No, I mean the combination of like awe and terror, you know?
Exactly.
I mean, did the eyewitnesses talk about how it made them feel?
Oh, yeah. Fear, confusion, like what the heck is going on? Like something massive and, maybe world ending was happening.
I can only imagine. And then about 10 minutes later, the sound hit.
Yeah, like a ton of artillery going off, one boom after another. The crazy thing is, the people closer to the blast, they said the sound seemed to move from east to north.
Really?
Yeah, then this shock wave, man.
How strong are we talking here?
Strong enough to knock people off their feet hundreds of kilometers away. Windows were breaking all over the place. And get this, seismic stations all across Eurasia picked it up.
Wow.
Yeah, not a direct impact, but the airburst, it was so powerful it registered on earthquake detectors.
So the whole continent felt it, basically.
Basically, airwaves from the explosion were detected in Germany, Denmark, Croatia, UK, even in Batavia, which is now Jakarta, Indonesia.
So Europe and Asia.
Yeah, and then get this, in Washington, D.C. too, they think in some places it was like a magnitude 5 earthquake. Imagine that, from an explosion in the air.
Crazy. That's a lot of power. But wait, there's more, right?
Oh, yeah.
What's this about the night sky looking different afterwards?
Yeah, for a few nights after, the skies over Europe and Asia were glowing. Seriously. There are reports from Sweden and Scotland, people taking pictures at midnight, no flash, because it was so bright.
No way. What caused that?
The main theory is that the explosion created a ton of tiny ice particles high in the atmosphere, and the sunlight bouncing off them caused this glow.
So it's like a weird side effect of this massive explosion.
Pretty much, yeah. And it's something we see with space shuttles re-entering the atmosphere, so we know it's possible.
Okay, so we've got glowing skies, but it didn't stop there, right? There was some other atmospheric stuff going on, too.
Right, so the Smithsonian Astrophysical Observatory in California, they saw a drop in how clear the atmosphere was, and it lasted for months.
Really?
Yeah, which makes sense if there was a bunch of dust kicked up by the explosion hanging around in the air.
Makes sense. Okay, so we've got the overview of the event itself. What about the people who actually saw it up close? What were their stories?
Okay, so there's this guy, S. Semenoff. He was at the Vanavara trading post, about 65 kilometers south of where they think the explosion was.
Pretty close.
Yeah. He said the sky split open and there was fire everywhere. He felt this heat like his shirt was on fire. Then the sky closed and there was this huge bang and he got thrown like several meters.
Oh.
He passed out for a bit, and when he woke up, there was this crazy noise, like rocks falling or cannons, and the ground was shaking like crazy. He even said there was this hot wind that blew between the houses, leaving marks on the ground and breaking windows.
It sounds insane, like total chaos. What about the Evenki people? They were right there, weren't they?
Yeah, they were. There's a story from a guy named Chuchan from the Shanyagur tribe. He was closer to the river.
Even closer.
He said he was asleep in his hut with his brother when they both got thrown out of bed. They heard this whistling and this really strong wind. They thought it was birds flying overhead, but they couldn't see anything. Then he got shoved again and fell right into the fire. They were terrified, calling for their families.
I can't even imagine.
Then they heard trees falling outside, like a ton of them, and then bam, this huge thunderclap, and more after that. He said the ground was shaking, their hut got knocked over, and then he saw it. Trees falling, branches on fire, and this light, like a second sun. So bright it hurt his eyes.
A second sun. It's wild, how even the language they use to describe it is so powerful.
Absolutely.
Okay, so we've got accounts from people really close by, but there were reports from further away too, right? Like in the newspapers.
Oh, yeah. The Sibir newspaper, they reported from this village, Karolinsky, about 213 kilometers north of Kurensk. People there saw this bright bluish-white thing in the sky.
213 kilometers, that's pretty far.
It is. They said it looked like a pipe or a cylinder, and it was moving down for about 10 minutes. Then as it got closer to the ground, it like smudged and turned into this big black cloud. And then this loud knocking, not like thunder, they said, more like rocks falling or cannons firing. And buildings were shaking. They even saw flames coming from the cloud. People were freaking out, thinking it was the end of the world.
I bet.
Oh, and the report also mentions someone near Kurensk who heard what they described as an artillery barrage, like going off again and again.
That's crazy.
What is?
So even that far away, bright lights, weird sounds, the ground shaking, no wonder people thought the world was ending.
Right.
Okay, so how did scientists even begin to figure out what caused all this? What did they think at first?
At the start, because it was such a huge explosion, everyone thought it was a big meteorite.
Makes sense.
Right. There was this guy, Leonid Kulik, a Russian mineralogist.
Yeah?
He was really into it. He led these expeditions to the area starting in 1921. He was sure they'd find a huge crater and be able to, get valuable meteorite iron from it.
But they didn't find a crater, did they?
Nope. And that's where things get really interesting.
Yeah, it was a big mystery, wasn't it? No crater. That had to make them rethink everything.
Oh, it did. When Kulik's team finally got to the area in 1927, they were shocked. No crater. Instead, they found this zone about 8 kilometers wide where the trees were scorched and had no branches but were still standing.
Weird.
Right? But then beyond that, they found this massive area, like 2,150 square kilometers, where the trees were knocked down, pointing away from the center, like spokes on a wheel.
Like something just pushed them outward?
Exactly, like if you drop something heavy on soft grass,
Mm-hmm.
but on a giant scale.
So not an impact, but something pushing outward.
Right. At first, Kulik thought some little holes he found were meteorite holes, but they didn't have the tools to really investigate them.
Oh.
And over the next 10 years, more expeditions kept going. Still no crater. They found bogs, but when they drained one, they found an old tree stump, so not a new crater.
Interesting.
Kulik did manage to get an aerial survey in 1938, which was a big help, but the original pictures were destroyed later, sadly.
Oh, that's a shame.
Yeah, but luckily, copies survived.
At least there's that. So no crater, but this huge area of flattened trees. What did scientists think was going on?
Well, the evidence started pointing to something called a meteor airburst.
Airburst.
Yeah, basically, the thing exploded in the air before it hit the ground.
So like a mid-air explosion.
Exactly. In the 50s and 60s, expeditions found these tiny spheres in the soil, silicate and magnetite.
Okay.
And they found the same spheres in the sap of the trees. When they analyzed them, they had a high nickel-to-iron ratio.
What does that mean?
Well, it's something you find in meteorites, not so much on Earth.
So space stuff.
Yeah, most likely.
But are those spheres only from space? Couldn't they come from, like, a volcano or something?
You'd think so, but the mix of elements and how many there were and how they were spread out, it all points to something coming from space.
Okay, so space stuff exploded in the air. Makes
Right.
sense. But was there any other evidence for that?
Yeah, they looked at peat bogs in the area, and the layers from 1908, they were weird.
Weird how.
The carbon, hydrogen, nitrogen, they had these unusual isotopic signatures. It's like a fingerprint, right? And these fingerprints didn't match anything in the layers above or below.
So different stuff.
Different stuff. And they found more iridium, which is rare on Earth, but more common in, you guessed it, space rocks.
Like in the dinosaur extinction event.
Yeah, exactly. The idea is that this iridium was debris from the object and fallout from acid rain after the explosion. But there's a catch. Some labs haven't been able to back up those results, so it's still a bit of a question mark.
So not totally conclusive.
Not yet, no.
What about that John Stone they found? Wasn't that thought to be a piece of the whatever hit us?
Oh, yeah, John Stone. A researcher named John Infantilov found this rock, and for a while, everyone thought it was a meteorite fragment. But when they analyzed it, it turned out to be from old volcanoes in the area, the Siberian traps,
Ah, so a false alarm.
basically. But there's a twist. In 2013, they found some tiny fragments in a peat bog, and some scientists think they might be from space, so the search continues.
The plot thickens. Because we've got no crater, trees knocked down in a weird pattern, and these tiny space particles. Airburst seems like the answer, but how does that even work?
Okay, so picture this. A stony asteroid, maybe 50 to 80 meters wide, enters the atmosphere super fast, like 27 kilometers per second. That's about Mach 80.
Seriously.
Yeah, super fast.
Mm.
So as it comes screaming in, the air in front of it gets compressed so much that it heats up like crazy.
Okay.
And the asteroid, it can't handle that, so it explodes high up in the air, 5 to 10 kilometers above the ground.
So it's not the impact that causes the damage, but the explosion itself.
Exactly. The energy released, they think it was something like 3 to 30 megatons of TNT.
Wow.
Early estimates said it was closer to the high end of that, but more recent models, they take into account how the object was moving, and they suggest the energy was probably more focused downwards, so maybe on the lower end.
Still massive either way.
Oh yeah. Just for reference, even 3 megatons is hundreds of times stronger than the bomb dropped on Hiroshima.
Just wow. Okay, so that weird pattern of the trees, that fits with an airburst happening way up high.
It does. Back in the 60s, the Soviets, they did these experiments. They set up model forests and set off explosions above them, and guess what? The trees fell in the exact same pattern. Right under the explosion, they were stripped of their branches, but still standing. Further out, they were knocked over, pointing away from the center.
Pretty convincing.
Yeah, and these experiments also suggested the object came in at a shallow angle, about 30 degrees to the ground and 115 degrees from north, which explains the shape of the flattened area.
So how often does something like Tunguska happen? Should we be worried about it happening again?
Well, thankfully, not very often. Maybe once every few hundred or even 1,000 years for something that big. Smaller airbursts are more common, though.
Like that one in Russia a few years back.
Yeah, the Chelyabinsk meteor in 2013.
Scary stuff.
Oh, yeah. Eugene Shoemaker, he was a planetary scientist. He figured that 20 kiloton airbursts happen every year. Newer research says even smaller ones, like 5 kilotons, could be happening like once a year. And they think most of these are caused by stony asteroids.
What about comets?
They tend to break up higher in the atmosphere.
Makes sense. Okay, so Chelyabinsk, that was a smaller version of Tunguska, right? What did we learn from that?
A lot, actually. That meteor was about 17 to 20 meters wide, and it exploded with about 500 kilotons of energy. Did a lot of damage, mostly broken windows, but over 1,200 people were injured.
Ouch.
The good thing is we got a ton of data from Chelyabinsk. Videos, sound recordings, actual pieces of the meteor.
So a lot more information than we had for Tunguska.
Way more. And it's helped scientists understand how these stony objects act when they enter the atmosphere. It's like having a mini Tunguska to study with all our modern tools.
So are we basically sure that the Tunguska event was an asteroid?
The airburst theory is pretty solid, but yeah, there have been other ideas.
Oh, I bet.
Back in 1930, this guy, FJW Whipple, he thought it was a comet.
Okay, so not a space rock, but a ball of ice and dust.
Exactly. Which could explain why we never found any big chunks of it. Comets can completely vaporize in the atmosphere.
I guess that makes sense. And what about those glowing skies?
Yeah, he said that could have been dust and ice from the comet's tail, reflecting sunlight.
Interesting. So what's wrong with the comet theory?
Well, in 1983, another astronomer, Zdeněk Sikanina, he wrote this paper that basically said, nope, not a comet.
Why not?
His main point was that a comet, being mostly ice and dust, wouldn't have made it as far down into the atmosphere before breaking up.
Ah, it would have exploded higher up.
Exactly. The fact that the Tunguska object got so low before exploding, it means it had to be something tougher, something denser, like a rock.
Makes sense.
Now, some people who still like the comet idea, they say it could have been an extinct comet.
Okay, what that?
Basically, a comet that's lost all its ice and dust and only has a rocky core left.
So it would act more like an asteroid.
Right. But no one's found any comet stuff at Tunguska, so that's a problem for that theory.
So it's still mostly pointing to an asteroid. What about other ideas, besides comets and asteroids?
Some pretty wild ones, actually.
Like what?
Okay, in 2020, some Russian scientists, they ran some simulations, and they came up with this idea of a glancing impact.
Glancing impact.
Yeah, they said maybe it was a giant iron asteroid like 200 meters wide, but it didn't actually hit the Earth.
What?
They think it might have just skimmed the very top of the atmosphere.
Really?
Yeah, and the interaction, like the friction and the heat, caused this massive explosion, and then the asteroid just bounced back out into space.
That sounds kind of crazy, but also kind of awesome. But wouldn't something that big, wouldn't we have seen it coming?
That's one of the problems with this theory. We should have seen more signs of it in the atmosphere before and after.
Yeah, that makes sense.
So while the computer models are cool, the glancing impact idea isn't really accepted.
Okay, how about Lake Checo? Some people thought that was an impact crater, right?
Right, so Lake Checo is this small lake, about 8 kilometers from where they think the main explosion was. In the mid-2000s, some scientists, they thought maybe it was a crater from a fragment of the Tunguska object.
Okay.
They said it had the right shape, and the bottom of the lake looked like a crater. They even thought they found a big rock under the sediment.
But that didn't pan out, did it?
Nope. Other scientists said there's no way a small piece of rock could have made a crater like that, especially after surviving a huge airburst.
Yeah, that makes sense.
And then in 2017, some Russian scientists, they did a bunch of tests on the lake bed. They found contamination from nuclear tests in the 1950s.
Nuclear tests.
Yeah, it's this marker that you find all over the world. And using that, they figured out how fast sediment was building up in the lake. And based on that, they said Lake Checo is at least 280 years old. Way too old to be from Tunguska.
So, mystery solved. Not an impact crater.
Right.
Okay, so we've covered space rocks and comets. What about things from Earth, like volcanoes or something?
Yeah, there have been some ideas about that. One is that a bunch of natural gas, maybe methane, suddenly erupted from underground and exploded.
Interesting.
The idea is that this gas went up, drifted with the wind, and then got ignited by lightning or something.
Then boom.
Exactly. And the fire went back down to where the gas was coming from, causing this huge explosion on the ground.
So, no space rock, just a massive gas explosion.
Right. There's also this idea called a Vernous shot, where you have gas trapped under volcanic rock and it explodes out like a giant champagne cork.
Whoa.
Yeah. And there are other, less specific ideas too.
But they're not the main explanations, Ro.
No, the main problem with these Earth-based theories is that we should have seen other evidence, like a huge crater or signs of intense heat on the ground or weird minerals.
Makes sense. And we haven't found any of that.
Right. Plus, they don't explain the space dust we found all over the place.
Right, that's a big one. Okay, so a lot of interesting ideas, but the asteroid airburst is still the leading theory. It's crazy that this event still has people coming up with new explanations, though.
Definitely.
What about, like, the cultural impact of Tunguska? You mentioned the Torino scale earlier.
Right, the Torino scale, it ranks how dangerous an asteroid is, and Tunguska, it gets an 8.
Out of 10.
Out of 10, which means certain collision with local destruction.
So, pretty bad.
Yeah, it shows that even though these things are rare, they can be really dangerous.
Oh, kidding.
And Tunguska, it's been in so many books, movies, you name it. People love a good mystery.
I guess it's the perfect setup for a sci-fi story, right?
Oh, yeah. I mean, you've got this huge explosion in the middle of nowhere, no clear answer.
Aliens.
Right. Alien spaceships, secret weapons, even black holes. People have come up with all sorts of explanations.
I guess that's how we process things we don't understand. We make up stories.
Yeah, and Tunguska, it's like the ultimate what-if story.
Totally. Okay, so after all this, what's the most likely explanation for Tunguska?
Based on everything we know, the best answer is that it was a stony asteroid, about 50 to 80 meters wide. It came in fast, exploded in the air, and that caused all the damage.
The airburst.
The airburst.
And we know this because there's no crater The trees were knocked down in a specific pattern, and we found those little bits of space rock.
Exactly. There's still some unanswered questions, of course, and people will always come up with new theories.
Think it will.
But for now, the meteor airburst explanation, it just fits the evidence best.
So after all this digging, it's clear why Tunguska is still such a fascinating event. It shows how wild and unpredictable our solar system can be.
For sure.
I mean, even in the most remote places, something like this can happen.
Yeah, and think about it. What if something like Tunguska happened today over a city?
Oh, man.
It's a scary thought, right?
Yeah.
Tunguska, it's like a warning from the past. It tells us that we need to keep an eye on the sky and be prepared for whatever might be coming our way.
That's a good point.
It's like the ultimate what-if story, but with real consequences.
Oh, well, that's something to think about.
It is.
Thanks for taking us on this deep dive.
Anytime.
And to everyone listening, keep those questions coming. We'll see you next time.
Bye.